Hi, welcome to my channel. In the previous video, we discussed about the definition of decision tree, and also some terminologies like root node, how can you represent the root node, and intermediate nodes, intermediate node, and leaf nodes, leaf node. Okay, and also we discussed about the types of decision tree algorithms. Regression tree algorithms like ID3, C4.5 and CART algorithm. And also we discussed about the how can you train the decision tree and how can you visualization of a decision tree, visualization of a decision tree. And also we discussed about the how can you make a prediction of a class level for the given input. Okay, given instance, like making the predictions of the class label for the given instance. Okay, using the decision tree. And also estimating the class probabilities of the estimating the class probabilities for the given instance with the help of our decision tree classifier algorithms. So, like that we discussed different topics about the decision tree. In this video, I am going to explain about our algorithm that is called as a CRT, classification and regression tree training algorithm. Okay. Now, for this we are using some standardized data set like iris flower dataset. Iris flower dataset. It contains four features like sepal length, sepal width, petal length and petal width. Okay, petal length and petal width. And corresponding species are iris setosa and virginica and versicolor. Here we are using the out of four features. We are using the petal length and petal width. Okay, and class level as a species. So that means we are having the x and y. X are nothing but here petal length and petal width, and corresponding y nothing but a species. Okay. Now it contains 150 rows. 150 rows, that means 150 instance are there and 5 columns are there. Out of 5 columns, you are taking the 3 columns. That is petal length and petal width as a x and y nothing but a species. Based on this information, we are constructing the decision tree. Okay, with the help of CART algorithm. CART algorithm is nothing but a classification and regression tree algorithm. That is based on the Gini index value. Okay. Now, the CART algorithm uses that means here we are using the scikit-learn uses the classification and regression tree algorithm, that is CART algorithm, to train the decision tree. So here the features are petal length and petal width. These are the features, and the corresponding class labels are Y. That is here we are using the setosa, versicolor, and virginica. Okay, now. Virginica. Okay. So there are the three features are there. So based on this information, you have to find out the corresponding class level. So that is the entire represent in the form of a tree-like structure. Okay. Now here this is also called as a growing trees. Okay. It is also called as a growing trees, and the algorithm works by the first of all you have to split the training set into two subsets using the single feature k and threshold value tk. So here, in our example, we are using the petal length and petal width as a features, and the corresponding class labels are setosa, versicolor, and virginica. Okay, these are three features, three class labels are there. Now, here our algorithm works by splitting the training set into two subsets. Okay, using the single feature k. So here, out of two features, we are selecting the one as a root node. Okay, based on one feature, we are going to split the data into two parts. Okay, therefore, based on the some condition on the corresponding feature. So, for example, here in our first root node, okay, we are having the petal length and the petal width. Okay. Now we are selecting the petal length as a root node. In this root node, we are going to split the based on some condition. Okay, that is called as a threshold value. Based on this some threshold value, we are going to split the data into two parts. Okay, so that is one based on this condition. If the condition true, whatever the elements that are lies below this condition, that becomes the left node, and whatever the elements that not lies on this condition, okay, that becomes the right node. Like that, we are going to split the data into two parts. Then, for example, here the petal length equal to less than equal to 2.45 centimeters. Then, how does it choose the K and the threshold value K, Tk? So this is a very important question. Okay, how can you choose the K value and Tk value? So here it searches for the pair of K features and corresponding threshold value. Okay, that produce the purest subset weighted by their size. Based on their size, we are going to divide that into purest subset. Purest nothing but all the elements are belonging to same class. All the elements that are belonging to satisfy the condition are belong to same class. Like that, we are going to split the data into two parts. So here the pair of K comma Tk is a very important. K nothing but a feature and corresponding threshold value. Okay. Now, the decision tree algorithm uses the CART algorithm. Internally, it uses the Gini index value. Internally, it uses the Gini index value. We will see what is the meaning of Gini index value. So here, you are going to use a pair of K comma Tk that produce the purest subset. So here, for example, the petal length equal to 2.5, less than equal to 2.5. Okay. 2.245. So here, if this condition is satisfied, all the elements are belong to same class. Okay, now here out of 150 elements, 50 elements are setosa, 50 elements are versicolor, and 50 elements are virginica. Now here, if the condition is satisfied, this condition, then all the elements are belong to one class. Okay, so like that, we are going to classify. So here, if you apply this concept, we are finding the Gini value equal to 0.0. That means here all the elements in the corresponding node, okay, belong to same class only. Then that is called as a purest. Okay. So here, splitting on the base of the feature K and the threshold value Tk, that based on this condition, we are going to split the data into purest subset. Here it contains all the elements. All the instances, like all the elements are all the instances. Now, if this condition is satisfied, the left sub contains a purest subset and the right also contains a purest subset. Like that, we are going to divide the data into two parts. So, like that, we construct the decision tree. Okay, here it gives the cost. Here it gives some cost function that the algorithm tries to minimize. Our aim is you have to find out the cost for the algorithm that minimize that cost function. Okay, here we are using some formula. That formula equal to J of K comma Tk, J of K comma Tk, K nothing but our feature and Tk nothing but corresponding threshold value. Okay, is equal to M left by M into G left plus M right by M into G right. That means here here M left or M right or nothing but is the number of instances in the corresponding left subtree or right subtree. Okay, and whereas G left or G right nothing but measure the impurity of the left subtree or right subtree. Okay, so like that we are going to find out the G left and the G right or M left or M right. This is also can be right in the form of a Gini index of T equal to 1 minus sigma of I equal to 1 to M. Okay, Pi square. Okay, probability of corresponding element to square. So that is okay. Then we are finding the Gini index with respect to target variable with respect to attribute A equal to mod of S1 by T into Gini of S1. That means here T nothing but the total number of elements in the corresponding subset entire instance. Okay, and S1 nothing but the number of elements in the subset 1. Okay, with respect to Gini of S1. Okay, plus S2 mod of S2 by mod T into Gini of S2. So here mod of S2 nothing but this is subset 1, subset 2. Okay, the number of elements in the subset 2 by the total number of elements in the entire set. Okay, mod T, Gini of subset 2. Like that, we're going to find the corresponding Gini index value. So with this information, we're going to find out the Gini value. Based on the Gini value, we're going to split the data into two parts. Okay. Now, once the CART algorithm has successfully split the training set into two parts, then it splits the subset using the same logic. Okay, then subsets, and it is recursively apply the all the nodes. Okay. Now it stops recursing once it reaches the maximum depth. It's defined by the max depth hyperparameters. Max depth hyperparameter, or if it cannot be find a split, that will reduce the impurity. Okay. So here, for example, in our example, our depth we are having the petal length and petal width. In the first condition, we are check the condition on the petal length. So here the petal length is nothing but a okay. If it is less than 2.5 centimeters, then if it is true, okay, all elements are belonging to one class and remaining elements are belonging to second class. Okay. Now here here the Gini index value equal to 0.0. That means here all the elements are belonging to same class. That means here we cannot further split the into two subclasses. Why? Here the Gini equal to 0.0. Okay. But whereas coming to here, if the based on this condition, we are checking one more condition. Okay. Here the data set contains 100 elements are there. Out of 100 elements are actually class 50 belongs to Setosa, vesicle, and 50 are belonging to Virginica. Now we are going to apply some condition, petal width equal to less than or equal to 1.75. So now once again, here we are going to split the data into two parts. Okay. If the condition is satisfied this condition, that is becomes left side, and if it fails, we are going to right subtree. Now here we are going to stop here. Why? Because of we are setting the max depth hyperparameter equal to 2. Max depth hyperparameter equal to 2. So that's why the level of the tree is 0 or 1 and 2. Suppose if you are not limiting the max depth equal to 2, then we can further split into two this level into one more level. Okay. Why? Because of here the Gini index value equal to 0.168. That means here the class label contains 0 Setosa, 49 belonging to versicolor, and 5 are belonging to Virginica. So if you apply the concept here, once again we can divide it into two parts. So that means 0, 49 and 0 is one class. Okay. And 0 and 0 and 5 are belonging to one class. Like that, we are going to split the data into two parts. This class becomes vesicolor, and this class becomes Virginica. And like that, we are going to split the data into this also into two parts. Okay, 0, 1 and 0. This one subset, and 0, 0 and 45 is one subset. Like that, we are going to split the data into two parts. If there is no max depth condition, okay, like that we are going to increase the size of the tree. That's why it's called as a growing tree. Okay, if there is no parameter max depth, okay, then the tree is called as a growing tree. Okay. Now the decision tree algorithm uses the CART algorithm. Okay, it is a greedy algorithm, and as it greedily searches for the optimal split at the top level. Okay, then it repeats the process at each level. Okay. Now a few other parameters control the additional stopping conditions, like here the class sklearn.tree.decision tree classifier contains different hyperparameters like criterion equal to Gini. So our algorithm uses CART algorithm. The CART algorithm internally uses the Gini value. Okay, Gini value. If it is a ID3 algorithm internally it uses the, instead of Gini value, it uses the entropy. So simply that is the difference between the CART algorithm and the Gini ID3 algorithm. And also here we are having the different types of parameters are like splitter and max depth equal to none, min samples split equal to minimum underscore samples underscore leaf equal to 1, min underscore weight underscore fraction underscore leaf equal to 0.0, max underscore features equal to none, random underscore state equal to none, max underscore leaf underscore nodes equal to none, and min underscore impurity underscore decrease equal to 0.0, and class weight equal to none, and CCP underscore alpha equal to 0.0 and monotic underscore CST equal to none. Like that, there are different types of hyperparameters are there. Out of all these hyperparameters, the main important features are hyperparameters are min underscore split samples underscore split and min underscore samples underscore leaf and min underscore weight underscore fraction underscore leaf and max underscore leaf underscore nodes. So here the different things are there, the hyperparameters are there that controls the construction of a decision tree. Okay, now the decision tree contain they are the different hyperparameters. Okay, now the CART algorithm is a greedy algorithm. It greedily searches for a optimal split on the top level, then repeats the process at each subsequent level. It does not check the whether or not the split will lead to the lowest possible impurities several levels down. So a greedy algorithm often produces a solution that is reasonably good but not guaranteed to be optimal. So like that we are going to train the our algorithm with the help of CART algorithm. Okay. So this is one of the best decision tree algorithm that is called as a CART algorithm. CART algorithm nothing but a classification and the regression tree algorithm. Okay. So unfortunately, finding the optimal tree is known to be an NP complete problem. It requires order of exponential of m time, making the problem interactable even for the smallest training sets also. Okay, and this is why we must settle for a reasonably good solution. So like that we are going to construct the decision tree with the help of a CART algorithm. Here we are using the Gini Index value. Okay, in the next video I am going to explain about the one example of the CART algorithm. Okay. Thank you for watching our video. If you like the video, please subscribe my channel. Thank you.